This is the first part of Euclid Book 4, proposition number 5. And we're going to do this in 3 parts. First of all, you're going to see a triangle here, and it starts at point A, comes down here to point B, comes over here to point C. And what you're supposed to do is you're supposed to circumscribe, in other words, draw a circle around this triangle. Now, how do you do that? Well, first of all, you're going to bisect line AB here. Going to bisect line AB here, and then you're going to bisect line AC here. Now, if you don't know how to do that, go back to Euclid Book 1 because there is a proof that tells you how to bisect lines. Okay. Now, we have had a line AB, and it has been bisected at point D, and a line AC, and it has been bisected at point E. Now, what you're supposed to do is you're supposed to draw a line, and you're supposed to start at point D, and it's to be at right angles to AB. Okay? And as you already know, that if you have a line that is at right angles to another line, then that line will also be perpendicular to that line. Okay? So in other words, this DF here, which we'll talk about F in just a minute, but this DF here is perpendicular to AB. Okay. Alright, DF is perpendicular to AB, FE is perpendicular to AC. Alright? Now, we now can say, because point D bisects AB, that the length of AD is exactly the same size as the length of DB. We can then go on to say that the length of AE over here is exactly the same length as the length of EC. This length is equal to this length is equal to that length. Okay? Now then, we can go on to say that DF is equal to itself in size. In other words, the length of DF is the same as the length of DF. Okay. We also then said that DF is at right angles to AB, okay, and that EF here was at right angles to AC. We can then go on to say that the length of AE and the length of EC are exactly the same. This length here is equal to this length here, and that the length of FE is equal to itself. Okay, FE is equal to FE. So what do we have here? We have side, angle, side. Same deal here. Side, angle, side. If you have side, angle, side, and side, angle, side, well, then you're going to have, hang on just a second here, you're going to have 2 equal triangles. In other words, a triangle ADF is going to be exactly the same size as triangle BDF. And triangle AFE is going to be exactly the same size as triangle CFE. And because of this, we can then go on to say that the length of AF is equal to the length of BF. Okay, so here's the length of AF here, and this length is equal to the length of BF here. These 2 lengths are equal. Then we can also go on to say that the length of CF is also equal to the length of AF. This length here is equal to this length here. Okay? Now, if we go on to say that, we can then say that line CF is equal in size to line BF. Well, then what you've got is a centermost part, which is F, and you've got 3 radii that are equal to each other. This one here, this one here, and this one here. So AF and BF and CF are all equal in length. So you could take any one of those 3, put your compass here on centermost part F, outermost part A, or centermost part F and outermost part C, or centermost part F and outermost part B. It doesn't matter which one you do. You can put your compass on F and any one of these 3 other points and make this circle. And you will make a perfect circle. Alright, I will tell you more in a future video, so stay tuned.